is William. I'm an incoming sophomore at Monte Vista High School, and I chose a ball tracking robot as my main project. So I chose this project because I thought there was a computer vision aspect, and I thought it was a good blend between hardware and software. So originally, the project is just a robot that tracks and follows a ball around. However, I made two modifications. The first one being a manual override using a Bluetooth app that allows you to manually control the robot. And the second one being this web server you see right here that streams the video from this camera onto it. I'll do the demo now. So as you can see, if the ball is in front of the robot, it'll move forward. If it goes to the right, it'll turn right with it. If it goes back to the left, it'll turn left. And if any object is too close, it'll reverse until it's far enough away. The demo's not finished. Manual override. Now it doesn't respond to the ball's position, right? It's not moving forward. I can make it go forward. Make it stop, turn right, turn left, go backwards, and if I turn it back to automatic mode, it'll start responding to the ball. So how does it work? So the software on the Raspberry Pi takes the input from this Pi camera, and it basically finds only the red pixels. So if you can imagine, the ball is a certain range of red pixels, some dark, some bright, and we want to find all the pixels that are within that range. So for every pixel captured by this Pi camera, it goes through, and if it's in the range, it colors it white, as you can see over there. All the red pixels of the ball are white. And after this, we want to find the biggest blob. That would be the ball. And then if you look closely on the left, there's like a little dot, and that would be the center coordinate of the ball. And bounding rectangle allows you to approximate the basic area of the ball. And using these two variables, you can calculate the relative position. So the area would be pretty small if the ball is farther away, and then the robot knows to move forward. If it comes closer, then it's too close, and the robot knows it's very high. And I use an online tool called MIT App Inventor that allows you to create a user interface and Bluetooth functions. So for example, if I press the forward button on my app, it will send an F character to the Raspberry Pi, and the robot will move forward. And for the second modification, which is the web server, I used a Python library called Flask to render an HTML template that captures this input from the camera and puts it on the website. When I was building this project, I faced a couple of challenges. The first one was when my motor just stopped working, and I didn't know why this was. All my code was perfect, my wiring was good. But I found out there's one bad wire that caused the whole thing to break apart. So once I fixed that, it was all good. And when I was working with these ultrasonic sensors, one of them burned out. I spent like 2 days trying to figure out why it wasn't working, and I found out it was burned out. So that kind of wasted a lot of my time. And before my two modifications that I made, I actually worked with object detection, and I actually got it to work, but it only ran at half a frame per second, so it wasn't very practical. I think after this, I would like to look further into object detection, see if there's any better models that I could use, and maybe make this an object tracking robot instead of just a ball tracking robot. I think my experience with Bluestamp was very fun. I learned a lot of things, especially about hardware and integration between hardware and software. And most importantly, I think I learned how to debug things and how to be a proper engineer. Thank you all for your time. Do you have any questions?